So first of all we start with the converter, and in the main function it calls it display hierarchy, and when we step into it we can see over here there's an external vector of the parent-child index, and parent-child index is nothing but the index of the child and its parent and the name of the game object, or the bone, I'm sorry. And so we can see that it's an extern, and which is filled up bottom over here by the pushback, and this ptemp is filled up over here, and we go through the current index, which is these. So this index is recursively called over here, and the main part over here is like we check whether the what's the attribute of the p node is. If the p node is equal to skeleton, then only we just recursive it, and we check for the p node is not null in the topmost part over here, and that would basically give us the whole structure of the bones, like who is the child and who is the parent of all. And in the main over here I have function get skeleton in file that would just open a file, write the bone header. Bone header just has the what number of bones does the skeleton has, and then writes the whole file that we're gonna use it in the engine to write it. Another part is the display animation, and in the display animation when we step into it, so this is the part where we have a for loop for each animation stack, that is each clip that is whole FBX is going to hold, and we run through it. And to write this I have actually clip header. So the clip header has so there are multiple extern over here, so these all are the main, and decline the main and used as an extern in another one. So let me go through what it's, and the clip header has the clip name and the number of frames on it. Bucket node has the keyframe number and number of bones that bucket has, and frame bone node has the bone data and also the bone index, which index it is on, and what's the keyframe, and then some padding. And while we go over here, this function is recursively called, and over here it goes through the each frame in the clip, and while we go through the each frame it's going to fill up the data. Over here we check whether it is not a eMarker, eMesh, eCamera, eLight, because these are all the 10 types that we don't need and it's a junk data, we can skip that. And over here then it's called recursively over there, and so that's pretty much it. It's recursively called, and all the frame nodes and the frame bucket nodes are filled up with it, which are this. They are filled up over here with the data. I mean we write the data of it in the end of the each clip. So basically I have file for the 3 clips and the file for the what do you call the skeleton. Let's go over the engine side. Over here I have 3 functions called, 3 files called skeleton loader, clip loader, and the model loader is on this one. Okay, we go to skeleton loader, and skeleton loader adds the file. So basically over here we read the whole chunk into the main buffer and then move the pointer towards the down. So first of all I'll fill up the main buffer with whatever file we have, and then the first we read the bone buffer that will say how many bones we have. Then I create the array of that particular object in over here, and then in the later part I just go through the for loop of it and create the game object. Before going into the for loop you need to add first object, because that would be linked up as an p rigid game object, that is rigid game object. And for this function I had to add this find function that goes through the game objects and looks for the index, which was not before earlier. And when we go to the clip loader, it's a kind of a same class but does the same kind of job. So over here again I read the whole thing, and p main buffer has the whole file. Read the clip header that I used to write first, that will tell me how many frames are there. Then I will create the frame bucket node. Frame bucket node holds the header of the each bucket, and so that I'll create the whole array of it, and over here I'll make the node of the frame bucket node. And understand that it's going to be a very big for loop while creating the new init and checking conditions and copy pasting the data. It's going to take a while for loading the data, but considering that we am using the pointers, it's going to be like, well, it's going to take time, but it's gonna do the job. And that would pretty much create the clip for us. Let me go into the game.cpp and exactly show you how it is done. So you just create the object, managers for the skeleton and the clips, and then over here you just do the skeleton loader add, and then this is the file skelly file, and then you pass in the name, and that will create the skeleton for the teddy bear. And over here the animation. So basically my whole architecture stands in like the there's a whole skeleton which holds the frame buckets. The skeleton holds the bone, and it's let me see if I have my diagram. Oh, there. Yeah, so game object manager owns the game object, and game object animation will point towards the skeleton because we have the p result bone in the skeleton and back and forth. So basically the whole, and the animation manager holds the animation, and animation owns the clip, and clip will own the frame bucket manager, and whole animation points towards which skeleton it is having, and skeleton will be having the object to the game object NMP root, which will be updated on the each loop. I'm going back to code. So that makes my game.cpp update function look something like this. So animation object manager is updated first, and so here it is, the animation update, which will find its t time, and it will process the animation and push that animation data to the skeleton. And then the game object update will basically call the game object animation update, and that will update the world position of all the game objects which is used in the later part down here. Oh my god, I'm so sleepy. Okay, in the skeleton manager, where the skeleton manager update will call the update on each of this on the skeleton, and that will do the set animation pose, that is pushing the p bone orientation back down, and that will be playing the animation. Yeah, I know it's a bit wonky. I don't know why my skeleton, my teddy bear is all moving all around while it is animating, but I guess it's pretty much it what I have right now. So that's the animation of that one, and I also have the animation of the idle. Wait, no, not this. There's Avast thing is always coming up. Okay, yeah. Again, still it's moving all around the place, but it's also playing the animation data around. So yes, my converted data do come into the engine and plays the animation data. I don't know why this whole translation thing is. I think that's what I'm going to debug next.